Hello everyone, welcome to Neso Academy. We have already completed chapter number 4, Control Structures and Functions. Now we are in chapter number 5 and the name of this chapter is Object-Oriented Programming. From this chapter onwards, we will dive deeper into the concepts of object-oriented programming, and the focus of this chapter is to understand the basics of object-oriented programming, or in short, OOP. This is the first lecture of this chapter, and the name of this lecture is Procedural versus Object-Oriented Programming. In this lecture, we will properly understand the difference between procedural programming and object-oriented programming. So, let's get started with this lecture and let's see what are the topics. There is only one topic in this lecture, and the name of the topic is Procedural versus Object-Oriented Programming. So, we will properly understand the difference between the two. Let's dive in and let's understand the difference. We have procedural programming and object-oriented programming. To understand the difference between the two, first we need to recall what is procedural programming. Up to now, whatever programs we have built were built using procedural programming. This means we have developed the programs that are all procedural programs. In procedural programming, the focus is on creating procedures, or in other words, functions. We know what a function is. A function is something that has the capability to perform some task. If we have multiple functions, then we would be able to perform multiple tasks. When these functions are combined together, then we would be able to solve a big problem. And that is exactly what procedural programming is. In procedural programming, the focus is in creating procedures, or in other words, functions. Through functions, we solve big problems. In procedural programming, we need to understand this, that the data and functions are separate entities, and programmer has to combine them to produce the desired result. Data and functions are separate entities in procedural programming. It is not the case that data is tied to the functions. It is the responsibility of the programmer to combine data and functions to produce the desired result. This can be understood through an example as well. Here, I'm calling some function called push, and to this function, I'm passing the arguments man and door. Let us assume there is some function called push, and to the push function, we are passing two arguments man and door. Here, the data has to be passed explicitly. While defining the functions, we need to define the parameters explicitly. Here, the data and function are not combined together automatically. They are separate entities, and it is the responsibility of the programmer to combine them to produce the desired result. When we pass data to the function, then only the function would be able to perform some operations on it and will eventually give us some output. So that is the case with procedural programming. Also, we can see that it is quite unclear whether man is the subject or door is the subject. So it is unclear who is the subject and who is the object. Or in other words, we can say that it is unclear to us whether man is pushing the door or door is pushing the man. So understandability is quite less in procedural programming, because procedural programming is quite unnatural way of programming. It does not mimic the real world entities properly. In real world, everything is an object with some properties and behavior. By properties, I mean data, and by behavior, I mean functions. Every object that we consider around us has some properties and behavior. Let's take one example. Let's take the example of a car. Car has properties like color, mileage, speed, or we can say maximum speed. Apart from this, car also has some behaviors. It has the behavior to stop, to start, or to move. These are different behaviors of the car. So clearly, an object has properties and behavior tied to that. So we can say data and functions are inseparable. That is what I have written here. Data and functions are inseparable. They both are tied together within an object. That is what we can see in the real world. Now, this modeling cannot be done with the help of procedural programming because the focus is on creating procedures or functions, and data and functions are separate entities in procedural programming. And with procedural programming, we would not be able to achieve scalability. That is, we cannot design big programs without making a lot of changes. If we want to add new features to the program, then we need to make a lot of changes in the program. So this is procedural programming. Now, this is not the only model of programming that we have. We also have object-oriented programming. Let's understand what is object-oriented programming. In object-oriented programming, the focus is on creating user-defined data types containing both properties and behavior. So what happens in case of object-oriented programming? The focus is in creating user-defined data types. So there is a shift in the focus. In procedural programming, we were focusing on functions or procedures, but here the focus is on creating user-defined data types that contains both properties and behavior. So properties and behavior are combined together within a user-defined data type. This is what happens in case of object-oriented programming. And an object is an instance of the user-defined type. By user-defined type, I mean a class. We call that user-defined type in object-oriented programming a class. And object is just an instance of the class. We can understand this through an example. What is the meaning of instance? Let's say we have the class vehicle. Vehicle has many properties and behavior, and these properties and behavior are common to all the vehicles that we see now. We have car, bike, truck. These are different types of vehicles. We can call these types as objects. They are the instances, or we can say occurrences of the class. They all have the properties and behavior of the class vehicle, but they are different in their own way. They have their own properties as well. They have their own behavior. But car, bike, and truck are all the objects of the class vehicle. So we can say an object is an instance of the user-defined type, or we can say an example of the user-defined type. I hope this is clear to you. Now let's take the same example of the push function, but in a different way in object-oriented programming. This is how the push function looks like, and this is how we can call this function. We need to call this function through an object, and that too with the help of the dot operator. And here you can observe it is completely clear that man is pushing the door. We read from left to right and we can observe that man is pushing the door. So it is clear that man is the subject, push is the behavior, and door is the object. So, one thing is clear that with object-oriented programming, we can design objects with properties and behavior inbuilt, and therefore we can model real-world entities quite properly. Hence, this is more natural way of programming compared to procedural programming. In object-oriented programming, we would be able to model real-world entities properly. That allows us to solve problems more naturally and efficiently. By efficiency, I mean that we would be able to design our programs with more scalability. You will observe this in a moment. why object-oriented programming is good for scalability. We would be able to add more features in the program without the need of modifying the program a lot. This is not the case with procedural programming. So, object-oriented programming is more suitable in those situations when we want to design big programs and when we want our applications to be more scalable. I hope this idea is completely clear to you. So, through object-oriented programming, we can model real-world entities, as you can observe. And modeling real-world entities is more natural as well, and it is more understandable. So, now we know in theoretical terms what is the difference between procedural programming and object-oriented programming. Now, let's understand why object-oriented programming is better in comparison to procedural programming, especially when scalability comes into picture. Here is the example program of a procedural programming. Here I have included IOStream and string header file. You will get to know in a moment why I have included the string header file. Here I have defined the enumeration vehicle with these two vehicles, car and bike. These are the objects of this enumeration. We know that car will receive the integer 0 and bike will receive 1. This is something we already know from the enumeration lecture. Now after this, I have defined the function giveName. The return type of this function is a string. This means this function will return a string. As the name itself suggests, this function will give us some name. Now to this function, we have provided the parameter vehicle type. So the parameter is type and the type of this variable is vehicle. So we are indeed passing the variable of this vehicle type. Now here is the switch, and based on this type, either of these cases will execute because type variable is passed to the switch. If type is equal to car, then this string car will be returned from this function. If it is bike, then the string bike will be returned. Otherwise, empty string will be returned from this function. I hope this is clear to you. So this is the giveName function. Now here is the function main, and in this main function, I have defined variable type of type vehicle. This means I have defined this variable of the enumeration type, and to this variable I have passed car. I can do this. Then here I am calling the giveName function and I am passing type variable to this function. Now what will happen? We know the type variable is holding car. So we are indeed passing car to this variable. Now we know this case is satisfied, therefore this string will be returned here. And we will get the output as I have a car when we execute this program. I hope this is making sense to you. Here you can observe that I have designed the procedural program. Here we have procedures. The focus is on designing the procedure or a function. Parameters are provided explicitly. Values are passed explicitly. Data and functions are separate entities. This is what we can observe. Now, what happens if we replace this car by truck to indicate that I have a truck? Let's replace car by truck and now let's execute this program. After execution, we will get error as the output. Now, why it is the case? We have not defined truck here in this enumeration. So we need to put truck here as well as the third vehicle. Apart from this, we need to make one more change. Here we need to add one more case of truck with return value of truck. Now when we execute this program, we will get the correct output, that is, I have a truck. Here you can observe that if we want to add an additional feature to our program, we need to make some changes in the program. Here we have made changes in the vehicle enumeration. Apart from this, we have made changes in this function giveName. This is just one function. Imagine if we have multiple functions, then we need to make changes in those functions as well. if it is the case that those functions are including this specific enumeration. So clearly, changes have to be made in lots of places in case of procedural programming. And this slowly becomes cumbersome as our programs scale. If we want to add new features, then clearly it will become so burdensome. And therefore, we need another programming paradigm. To model real-world entities, and if we want scalability, then we can go ahead with object-oriented programming. Now let's design the same program through object-oriented programming. This is how we can design our program. Here I have defined a class, and the name of this class is vehicle. This is the user-defined type, just like the enumeration. So here I have defined a new type called vehicle. In this class, I have specified the public keyword. The meaning of this public keyword is that whatever the code we write after this public keyword is publicly available. This means it is available to all the functions of this program. Here I have defined this variable type of type string, and here is the constructor called vehicle. This is a special kind of function in a class which gets executed when we create the object of the class. And this specific function will receive some string in this variable t. And this string is provided to the variable type. Here you can observe that we do not have to explicitly pass the variable type to this function. Here the variable type is available before this function and it is accessible to all the functions we define in this class. So its accessibility is all the functions of this class. And therefore we can directly use the type variable here. So we can say data and functions are tied together. It is not the case that they are separate. If we can observe data and functions are tied together in this class. This variable is accessible to all the functions. Here we are directly using this variable without the need of passing this variable explicitly. Apart from this, we also have one more function giveName. And this function will return string. We know it should return the string based on the type variable. Here, we are directly writing the statement return type. You can observe that the type variable is used directly because functions and data are tied together. They are not separate entities. I hope this is clear to you. Now, here is the main function. I have defined the object of this specific class. You can observe the type is vehicle and the object name is my vehicle. And within parentheses, I have passed this string car. Now, this string will be received by this constructor. As I have already mentioned this, when we create the object, the constructor is invoked. And this variable will receive this string, and this string will be passed to the variable type. I hope this is absolutely clear to you. Now, here is the call to the giveName function, that too through this object myVehicle. Here we can observe that when myVehicle object has been created, the type variable has received the string car. Now we can say that this type variable with this specific value is associated with this object. Here we are calling this function giveName with the help of this object. So this type variable receives car as the string and this will be returned to us. So now this variable type, which is local to this function, receives the string car. Now with the help of stdcout, we can display the message, I have a car. So I hope this is clear to you. We are getting the same output as before. And now we have this object-oriented program. If many of the concepts are unclear to you, then there is nothing to worry at this moment. We will understand these concepts as we proceed in this course. So do not worry about this. We just need to get the essence of object-oriented programming here. Here we got the output, I have a car. Now, What happens if we want to display I have a truck? Hey, we just need to replace car by truck. And when we execute this program, we will get the output I have a truck. Now you can observe that we just have to make change over here. There is no other change required in this program. This program will work as expected. We will get the output I have a truck. And clearly we can observe that object-oriented programs are more natural in comparison to procedural programs. And when scalability is the concern, then object-oriented programming is much better compared to procedural programming. If we want to add more features, then we do not have to make changes in many different places in object-oriented programs. So, for scalability purposes, definitely object-oriented programming should be chosen. So with this, we have understood the difference between procedural and object-oriented programming. Procedural programming is good for small programs, and it is quite easier for us to write procedural programs as well. Object-oriented programming can be a little difficult to understand and write, but at the end, we will achieve scalability. Therefore, if we want to design big applications, then object-oriented programming must be the choice. So with this, we have understood the difference and we are done with the topic procedural versus object-oriented programming. This means we are done with this lecture. Okay, friends, this is it for now. Thank you for watching this lecture. I will see you in the next one.